Hey, good day. In this video, we will talk about division of polynomials, and that is the long division of polynomials. Okay, polynomial long division is a method for dividing a polynomial by another polynomials of a lower degree. It is very similar to dividing numbers. If you look at the setup of arithmetic long division and the polynomial long division, it's just the same, only that the arithmetic long division involves only numbers or constants, but here we have variables. So expression, an algebraic expression. So as you can see, we have here the divisor, we have here as well the divisor. Quotient, here quotient. And then the dividend will be inside this long division symbol. And then we have here a remainder as well. If there's a remainder for polynomial long division, as you can see here, it is already a constant here. It is a remainder when it is no longer be divided, or it cannot be divided anymore by the divisor. Or when you divide this by the divisor, it will not give us a whole number answer. So meaning to say that's already your remainder. So now, let's continue. So as you can see, in this given, we have the following. So the steps, we only have 2 steps to remember when dividing polynomials using the long division. Number 1, arrange the polynomial or the dividend and divisor in descending order. Meaning to say, we have to arrange the degree of the polynomial from highest down to the lowest degree. Second, if a term is missing, insert 0 as a placeholder. Okay, so example, when we divide 4x squared plus 5x minus 1 by x plus 1, we get the answer. This is our answer. So we can rewrite it in this form, 4x squared plus 5x minus 1 all over x plus 1. So how do we get this answer? That's what we're going to discuss. So the answer will be written like this: the quotient, and then the remainder, and then the divisor in fraction form, this part. Okay, so the polynomial, if we're going to look at it, it is divided, or it is categorized into 4. So the number inside the division symbol, or in this case, if it is written like this in fraction form, in the numerator, that's what we call the dividend. Okay, and then the number below, or in the denominator, we call as the divisor. That is x plus 1. That's the divisor. And then this one, 4x plus 1, is our quotient, or the answer. And we have the remainder, negative 2, plus it is only written here. In this case, it is written in fraction form. So negative 2 all over the divisor, which is x plus 1. Okay. Now, given that f of x, if you look at it, f of x is the function, or is the given polynomial, and d of x, which is the divisor, are polynomials. Both of these are polynomials, the dividend and the divisor, wherein d of x should not be equal to 0. Otherwise, if the divisor is 0, it becomes undefined. And the degree of the divisor, or d of x, is less than or equal to the degree of f of x. Okay, then there exists a unique polynomial, quotient, or qx, and our remainder, which is rx, such that f of x is equal to the quotient times the divisor plus our remainder. Okay, again, it is written in this form. So f of x is equal to qx times dx plus the remainder, rx, where the degree of rx is less than, or the degree of the remainder is less than the degree of the divisor. Okay, in a special case wherein rx is equal to 0, we say that dx divides evenly, meaning to say it is a factor. So let's begin by giving you an example, or by showing you an example in this video on how to divide or to perform long division. Okay, look at this. Divide using long division, negative y squared plus y cubed plus 25 divided by y minus 3. If you look at this, this is not written in standard form. So we have to rewrite that in standard form. And if you notice, also, there is a missing exponent if we arrange this one. So since there is a missing exponent, if we arrange this, 2y cubed, after that, supposed to be, that is y squared, and supposed to be y raised to 1. But there's no y raised to 1 here, or a linear exponent. So we have to place 0 as a placeholder for that particular missing exponent in the given expression here. Okay, now, so rewrite that in a descending order. Rather, we have to rewrite this one in descending order. 2y cubed minus y squared plus 0y plus 25. So after the linear, meaning to say the term with an exponent of 1, after that should be the constant. Okay, step number 2. Write division in the same way you would when dividing numbers. So we're gonna write that in the same way we divide numbers, or with this, in the same way we divide using an arithmetic long division. Okay, so we have that set up. Next, step number 3. So this is just the continuation of our given in the previous slide. So we have 2y cubed. We're gonna divide this 2y cubed divided by y. So again, we will just divide the first term by the first term here. So 2y cubed divided by y is 2y squared. So let me put it here inside. So we have 2y cubed. If you divide that by the first term, so again, first term, first term. So 2y cubed divided by y is going to be 2y squared. And as you can see, this 2y squared, I placed that aligned with the given wherein there is also an exponent of 2. So alignment is very important so that you will not miscalculate this. Okay, next. So after that, sir, how did you get this part? After that, we gonna multiply 2y squared. You're going to multiply that to the whole of this, y minus 3. So, and then distribute, it's going to be 2y cubed, and then multiply, this is going to be, that is negative 6y squared. And as you can see, this number is now this, or this expression we put in here. Now, after that, we're going to subtract. So we subtract, we have this, and since we are subtracting, all the sign here will change. So this becomes negative already, and this becomes positive already, and then we proceed to adding. Now, adding unlike or terms or an expression with unlike signs that are the same or opposites, we call this one opposites. Terms with the same numbers and variables and exponents, as you can see, 2y cubed exactly alike, but their sign are opposite, we can just cancel that. Okay, so no need to write 0 here, but if you want to write, you can also write that, but since it has no value, we don't need to write that. Now we are adding negative y squared plus positive 6y squared. So therefore, apply the rule on adding integers. So we have 5y squared. And then bring down this. Okay, after that, we're gonna divide this term by this term. So we have 5y squared divide by y. Again, first term, divide by first term. First term of here, divide by the first term of the divisor. So we have 5y. So where will I place this? 5y will be placed here. As you can see, we have exponent 1, we have exponent 1 as well. So after that, we're going to multiply this to our divisor. So that's just a repetition of the process. So 5y times y is 5y squared. And then 5y times negative 3 is negative 15y. So we will place it here. Okay, now, again, repeat the process. We will subtract. So subtracting here now will give us, this becomes negative, this becomes positive, and then we change to addition. So adding this opposites terms or expressions that we have here, so we can cancel that out. And then 0y plus positive 15y is going to be 15y. And then we just bring down this here. That's why we have 25. Okay, next. So after that, what we're going to do is to divide again this one. Divide 15y by y. So again, first term divide by first term. So cancel this out, becomes 15. So where will I place 15? It should be aligned with the constant as well. So constant, constant. So align. So now after that, repeat the process, multiply this to the divisor. So then, distributive property, we have 15y minus 45. So we place it here. Now we subtract. So in subtracting, we will change all the signs here. This becomes positive and this becomes addition now. So cancel this one. As you notice, all the first terms a while ago are being canceled. Now, 25 plus positive 45 is 70. So that's how we divide. Now, sir, how will we write the quotient? So the quotient will be written like this. Step number 4, write the final answer in this form. So again, this is our final answer. As you can see, we have our quotient 2y squared plus 5y plus 15 and then plus the remainder 70 will be your numerator and the divisor here will be your denominator in your final answer. This will be our answer. Okay, let's have another example of that. Take a look at the second example that I have. Let's see if this is written in standard form. It is written in standard form because the degree is decreasing or the degree of the terms is decreasing. So it is arranged in descending order. But notice that the terms or the degree rather of the terms here are missing. There are degrees that are missing. So 3, it's next to 3 should be, the exponent should be 2. So therefore, we will add 0 as a placeholder for that. So instead of 6x cubed plus 4x, first we will add 0x squared. So this is a placeholder since we have to complete the degree. 3, 2, 1, then 0. Okay? Then plus 4x. So the degree of this is 1. We all know that. Whether we write it or not, it is understood that it is 1. So minus 12. And then we draw the division symbol here. And then we have to write 2x minus 1 here. Then we do the process. We divide the first term by the first term. We have 6x cubed divide by 2x. If we divide by 2x, 6 divided by 2 is 3. X cubed divided by x is x squared. So notice we just subtract. There is an exponent here. So x, copy x, variable x, and then 3 minus 1 becomes 2. So that's why we have 3x squared. Where will I place that? I will place that also aligned with the exponent in the given, that is 2. So we have 3x squared placed here. It should be aligned. Next, after that, 3x squared will be multiplied to the divisor, which is 2x minus 1. So multiplying becomes 6x cubed. This one becomes negative 3x squared. And we will write this here. Okay, we have 6x cubed minus 3x squared. So as you can see, the alignment is there. So the same exponent, the same exponent. Now we do the subtraction. So we place here, change the sign. This becomes negative already. And then this becomes positive. So a while ago, this is negative now, change from positive to negative, and then this one now becomes positive, and then change to addition. Now, let's proceed and perform this. So adding this one, we can cancel that out. Exactly alike, but the signs are opposite, just cancel. Then 0x squared plus positive 3x squared is 3x squared. And then bring down. We're going to bring down 4x. And then from there, we're going to divide this one first term by another first term. So 3x squared. Let's see if it is divisible. We have 3x squared divided by 2x. So we have this one. 3 divided by 2 cannot be divided. It cannot be divided. It will not give us a whole number answer. So we'll just retain that 3 halves. And then this becomes what? X squared divided by x is x. So we will place this where? Here. Okay. Plus 3 halves x. Okay. Next. After that, what's next? We're gonna multiply 3 halves x to our divisor, which is 2x minus 1. Distribute, we're gonna multiply. This becomes 3 times 2x. 3x times 2x is 6x squared, divided by 2 is 3x squared, so 3x squared. And then 3 over 2x times negative 1 is negative 3 over 2x. Okay, that's it. So where are we going to place this? We're going to place that here. So 3x squared minus 3 halves x. And then after that, we do again subtraction. So subtract, and then we change the sign. This becomes negative. This becomes positive. So then add. Now, cancel this out. And then we perform the addition here. So we have adding 4x plus positive 3 half x. What will be our answer? We can write at this one as 4 and 3 halves, positive 4 and 3 halves x. Or if you want, you can rewrite this in improper fraction form, and that is 11 over 2. So we can have this one in 11 over 2x. Now bring down 12. We bring down 12 here. So minus 12, sorry. So that's going to be minus 12. And then after that, next we're gonna divide this first term by first term here. So dividing 11 over 2x by 2x. Okay, let's perform that here. So 11 over 2x divided by 2x. So as you can see, if we divide 11 over 2x divided by 2x, we can cancel x, cancel that, and then 11 over 2 divided by 2 becomes 11 over 4. So that's 11 over 4 here. So if you want to check, just check it using your calculator. That's going to be 11 over 4. Since this is positive, I will put plus 11 over 4 here. Okay, now after that, 11 over 4 will be multiplied to 2x minus 1. Okay, distributive property. And this becomes now 11 half x. So 11 half x and then minus 11 over 4. So 11 half x minus 11 over 4. As you notice, this one should be the same. Look, the same, the same. So that we can cancel that out. So now, if we subtract, change the color, subtract, this one will change. This one also will change. This becomes positive already. Okay, so then add, cancel. Then we perform. Negative 12 plus positive 11 over 4. So go and if you have your calculator, we have negative 12 plus 11 over 4. Okay. So that is negative 37 over 4. Negative 37 over 4. So this will be our remainder. Now, how are we going to write our final answer? Let's write our final answer. Let me erase this part. Our final answer will be written like this. Okay. Let's rewrite our final answer. Our final answer will be this, the quotient, which is 3x squared plus 3 halves x plus 11 over 4. Then we can have this negative 37 over 4 all over our divisor, which is 2x minus 1. So this can be accepted, but if we can still simplify this part, but this is already accepted as our final answer. Okay, so let's have the third example. Now, on the third example, we have 15x squared plus 8x minus 12 divided by 3x plus 1. So again, let's examine the given if it is arranged in standard form. Yes. So x squared, then 1, and then here constant. Okay, yes. So let's write this one in the setup that we have for division. 15x squared plus 8x minus 12. So we draw the division symbol for a long division. So we have 3x plus 1. Okay, again, divide first term by the first term. So 15x squared divided by, so let me put it here, 15x squared divided by 3x, it's going to be 5x. So 5x will be placed here, and then 5x will be multiplied here. So again, multiplied to all. So 5x times 3x plus 1. So multiply becomes 15x squared. Multiply, this becomes 5x. Now, we will write this part here. So 15x squared plus 5x. As you noticed, always this one becomes the same and it will be cancelled. So we can just cancel that out. So negative, this becomes negative, this becomes negative. So cancel this out. As we add, we cancel that. And then 8x plus negative 5x becomes 3x. And then bring down, this becomes 12. And then next, divide this by the first term of the divisor. 3x divided by 3x is 1. So where are we going to place this one? Here, aligned with the constant as well. So positive 1. Then 1 times 3x plus 1. So we will multiply this. We have 3x plus 1. Okay, we put it here. 3x plus 1. Now, as you can see, it's still the same, this one. So we can cancel this out and this one. So change the sign first and then proceed to addition, then cancel. So now this becomes negative 12 plus negative 1 is negative 13. This will be our remainder. Okay, now final answer will be written like this. 5x plus 1 minus 13, that's in the numerator, all over the denominator, which is 3x plus 1. Okay, this is our final answer. Let's have the last example. Let's perform another long division. So let's see if this is also arranged in standard. So x squared, then follow after x squared should be the linear exponent or an exponent of 1 and then constant. So yes, it is arranged in standard. So we go right away to the setup that we have for long division. We have x squared plus 5x minus 28. And then we draw this. Then x minus 3. So now, if we get familiar already with the process, no need to write here the process in dividing this. So x squared divided by x, it's going to be x. Multiply this x times x is x squared. X times negative 3 is negative 3x. Okay. Now, we subtract, we change the sign of this, becomes negative. We change the sign of this, becomes positive, and then we add. So cancel this out, and this becomes 5x plus positive 3x is 8x minus 28. So we just bring down 28 here. And then we divide. 8x divided by x is 8, positive, so plus 8. 8 times x becomes 8x. 8 times negative 3 becomes negative 24. Now, we can cancel this one again. This becomes negative. This becomes positive. Cancel. Adding this becomes negative 28 plus positive 24 is negative 4. Therefore, this is now our remainder. Now, let's write our final answer in this form. Start first with the quotient here, which is x plus 8. And then followed by the remainder, which is negative 4, minus 4 over our divisor, which is x minus 3. Okay? So that's how we divide polynomial with another polynomial that is a degree less than the given dividend. Okay, thank you and see you on the next video.